Hey, good morning, good afternoon, good evening. We are back. So sorry for that. We are in Florida and the temperature is very high, 32 degrees Celsius here. So my phone died. And that's the reason we basically have to relocate indoor and enjoying the air conditioning here with my host. So how are you guys? Sorry. Now we are cooling down. We are better. So let me introduce them. So first we have Kevin. Hi, Kevin.
Hi.
So Kevin, you are located in Los Angeles, California, like everybody here.
A little south of Los Angeles in Orange County. But yeah.
And your main activity is not citizen astronomer at the SETI Institute, right? You have a job.
I do have a full-time job. I am a high school Earth and Space Science teacher.
Okay. Then we have Rachel. Rachel, how are you?
Hello, everyone.
So with something I should say is that it's the first time we see each other in person, all of us. That's basically. Right? It's kind of interesting. So Rachel, you're also in Los Angeles, or nearby?
A little north of Los Angeles.
Okay, and you also have a real job, I'm assuming.
Yep, I'm in the biotech industry.
Okay. And you're also a citizen astronomer.
Yes.
And then Brad, how are you?
Hello.
So you together, right?
Yes.
So...
yes. And I'm in biotech as well, a data scientist.
Okay, and you also enjoy the unistellar telescope to do observations.
Yes.
And then behind me we have Arin. Hey, Arin.
Hello.
So Arin is a grad student, right? No, undergrad student. No.
Soon to be grad student.
Soon to be grad student. Where?
At UC Berkeley.
At UC Berkeley. And also Arin and I work at Unistellar.
Yep, on exoplanet.
Exactly. So if you have complaints about the speed of the data processing for the unistellar planetary exoplanet transit program, is this fault? All right. So my name is Franck Marchis, and I'm gonna be the host today. I'm gonna try not to speak too much. The reason we are here is because you had the opportunity to come to Florida to see the launch of the Lucy mission. So I'm going to ask for one volunteer to summarize in less than 1 minute what is the Lucy mission. You volunteer.
So the Lucy mission is a groundbreaking mission. It's the first of its type to visit the Trojan asteroids in the Lagrange points, both preceding and trailing Jupiter. And the interesting thing about these gravity wells is that they have the ability to capture asteroids from the very earliest parts of the solar system. And so more so than other main belt type of asteroids that we've been able to look at and study, we have an opportunity with Lucy to see asteroids that come from the most primordial parts of the solar system's beginning. And, not to have too much of a spoiler, that's where the name Lucy comes from. And I think we'll probably get into that later too. So in 1 minute, there's your synopsis.
Very good. I think the NASA people would be very happy to hire you to talk about the Lucy mission next time. So Lucy is going to be launched tomorrow. Okay. And we are all going to wake up at 2 a.m. or not going to bed. Choices. To go to see the launch. It's going to be a night launch, in fact. And I've never seen myself a night launch, so I'm kind of excited to see that. So what did you do today? Tell us, what was the program?
So we went to the Kennedy Space Center to pick up kind of the credentials for tomorrow's launch, and then got to see a lot of the exhibits kind of at the Kennedy Space Center, plus a mission briefing, which is where some of the scientists, some of the engineers, some of the Lockheed Martin people were there to kind of talk about the various parts of this mission, how it arose, what the rockets look like, and kind of the asteroid targets that it's going to be seeing in its 12-year journey. 12
years. That's a long time, right? So I'm going to have a quiz. What's the first asteroid that's going to be visited by the Lucy mission?
Johansson.
All right. So someone can tell us why this asteroid, what's the name of this asteroid coming from?
It was the person who discovered Lucy.
Yes. Mm-hmm. Okay. So it's called the Lucy mission.
It's called the Lucy mission because Donald Johanson discovered a 3.2 million year old hominid, which is, I don't want to use the term missing link, but represents one of the stages within human evolution. And what we're hoping with the Lucy mission is that we get to see an early stage in the evolution of the solar system. And so I think Lucy is an extremely appropriate name for a mission of this type that really is looking for the very beginnings of our solar system, similar in ways to the hominid Lucy being the beginnings or early stages of human evolution.
Hey, so why were we invited to this? Someone can tell. Some of the people here watching us may wonder why the four of you were invited to this launch.
Well, all of us were able to observe the occultation of the asteroid Patroclus in Los Angeles, which I believe is one of the last asteroids that Lucy is planning on visiting. So by doing so, we were able to learn more information about the size and the shape of this asteroid before Lucy arrives.
So Patroclus is going to be the last one. It's in the L5 Lagrange point, but before this, the mission is going to visit the L4. How many asteroids? Do you know how many asteroids roughly? I think it's 4 or 5 asteroids, right? We can talk about them. There is Horus, Eurybates, Polymel, Locus. That's 4 of them. Did I miss one of them?
The Donald Johanson, but
Yeah,
it's a
but
main
that's
belt
Amendment.
asteroid,
That's Amendment.
and then the 2 in the L5.
Yeah. So it's interesting that this mission is not going to orbit around those asteroids. This mission is going to fly by. Okay. And the reason the contribution of citizen astronomers like you is important is because with your observations of occultation, we get the shape, the size, the position, and that allow NASA to kind of have an idea of what the spacecraft is going to visit. So imagine that we launch a spacecraft at 12 kilometers per second to visit an asteroid. There is a bunch of cameras on board. There is 3 instruments, in fact, and they have to, in the very short amount of time, typically 3-4 days, take as many pictures as possible of the asteroids. So take the overview using the LORRI, this big camera, the eagle eye, they call that. And then they will take some narrow observation to look some specific area on the surface of the asteroid. And for that, they're going to use a spectrometer to derive the composition of the asteroid, thermometer to derive the temperature of the surface. So why did you participate to this observations? What was the motivation, except waking up or going to bed at 1 a.m.?
I think having kind of the call come down and knowing how many people in Los Angeles in particular have kind of a unistellar telescope, we knew kind of there was going to be multiple shots on goal. And I think, how many did we get? 5 people managed to capture various points from the unistellar network alone, plus quite a few other folks with different telescopes, manual telescopes, were able to capture it. So it was lucky that it passed through a nice urban area where a lot of us were able to kind of look at it in the sky.
Nice. Yes, so this was an opportunity that we had in May. I think it was in May, right?
Mm-hmm.
And there will be more of those occultation in the future, in fact. And as you mentioned, the mission's going to take years to go over there. So in the meantime, the contribution of citizen astronomers, part of Unistellar Network or IOTA or any other groups, Recon, will be extremely useful. So I would like to say thank you to Damien, who gave us some stars on YouTube today, and also to thanks people watching us from Buenos Aires, Victoria, British Columbia, South Carolina, Baltimore, Albania, Kentucky, Belgium, Maryland. That's kind of a diverse group of people here. Thank you very much for watching us. We are talking about the Lucy mission, which is going to be launched in a few hours, in fact. So what's the program now? We are, so you have seen first of all, who were talking at this meeting that you went to? Do you remember the name of these people and their roles?
Let's see. So we had a program manager from Lockheed Martin. I will not remember names, I'm sorry. We had the rocket launch, the ULA.
Yeah.
A few NASA folks. Sorry if anyone remembers names, feel free to jump in.
It's okay. So, but the reason that Lockheed Martin was represented is because they built the spacecraft. So they built the platform basically, and they integrated the spacecraft. NASA is the main contractor, of course, and then UAL is the launch vehicle. So I was lucky this afternoon because I was one of the few people who could go to see the rocket. I'm sorry. So I took some picture that I'm gonna share with you. I think it's the first time I see a rocket that close. In fact, it was not that super close. I was hoping to be able to touch it. We were like 50 meters away from it, but it's still impressive to see a rocket even from that far away. You will see on the picture on the top of the rocket, they drew the logo of the mission, which is basically the spacecraft and the NASA binary asteroid in the background.
And I'd like to mention that logo also features the Lucy, the hominid Lucy that Donald Johanson discovered as well.
Yeah, I think it's a good idea that they link together astronomy and paleontology in this case, so we say, because the project Lucy is truly to understand the past of the solar system. Okay, so we are ready to take some questions from the audience. So I'm going to read a few of them that I received here. So how will Lucy avoid being hit by debris? That's a good question. Someone want to answer to that, or I do it?
I can speak to it a little bit. Contrary to popular belief, the asteroid belt and the Lagrange points are very empty. There's on average 1 million miles between different objects. But that having been said, there is concern about some of these asteroids potentially having clouds of debris around them or potentially rings. And I do happen to know that they're going to use some of those instruments as they approach the asteroid to look for that kind of debris as they're approaching. And there's enough delta V on the spacecraft for them to make some maneuvers as they are approaching.
So it's and also the reason we're doing occultation is for that. In fact, the first time we discover rings around asteroids, or the first time we discover moons around asteroids, that was through occultation. The first moon was discovered in 1980s around the Cleopatra asteroid, and at the time people say no, it's not possible because theorists believed that it was impossible to have moon around asteroids. So it took us 20 years to convince them. And then the first ring was around the centaur, and of course the name escaped me right now, and that was discovered typically 10 years ago. So with this occultation that we are doing, we can also detect the surrounding of an asteroid. And that's why it's important to do this type of research. I have another question. What does this mean so much to all of you? Why? Why do you care? I'm a researcher, so for me, it's my field of research. So I would just say that it's basically my, it's my passion. I would say that observing stars and studying asteroids always been kind of the main purpose of my research. So Lucy is truly the mission to explore the unknown in the field of asteroid. What about you?
I think it's very important to understand our origins as a solar system. As Earth, asteroids and meteorites are fundamental to understanding the origin of Earth. All radiometric dating is done with, meteorites as their basis. So I think understanding our origins and helping and contributing in any way you can is, it's for me essential, and for graduate school.
Someone else want to answer this question?
Being a teacher, I like to bring real life opportunities to bring real life science to my students. So for me, it's an opportunity to participate in science in addition to teaching science. And so the ability for me to do this, to participate in science and to take that back to the classroom is really a motivating factor for myself.
Okay.
It's been fascinating for me kind of participating in science in such kind of an easy way. And it always amazes me how much we don't see. kind of typically, and having little backyard telescopes can actually do something, and it's so relatively easy. It doesn't require a degree, though I appreciate people that are getting degrees in this, but it just having that little contribution to something that, frankly, this mission has been in the works since I think 2017 is when it got approved. It's going to be going through 2033 is when it does last pass by, and then it's just going to hang out there. So it's going to, it has potential to kind of help contribute to science kind of in the long term.
Brett, you good?
Hey, I enjoy looking up and wondering what's there, and it's just a relaxing thing to do and to hang out with my wife.
That's a very good reason, I think.
Mhm.
All right. Yeah, some people join us late and ask to explain again why Lucy. So Kevin, you did that perfectly at the beginning. So do it again, please.
So Donald Johanson, the namesake of the first sort of test asteroid that the mission is going to pass, discovered a 3.2 million year old hominid, which is a precursor to humans, somewhere in the line of evolution. And so Lucy is the name given to this this skeletal remains of this early ancestor of humans. And it has taught us a lot about the evolution of early humans and early hominids, you know, and our early beginnings as a species, although Lucy's certainly not human. The mission Lucy is trying to do something similar with asteroids. The Lagrange points around Jupiter have an interesting gravitational ability to grab onto these asteroids and hold them in place and not allow other asteroids to enter. And so we believe that the asteroids we find there are going to be very primordial. They're going to be asteroids from the very earliest times of the formation of our solar system. And so they have the ability to tell us about the early evolution of the solar system in a way that the skeletal remains Lucy have taught us things about the early evolution of hominids and eventually the line that led to human beings.
Very good. Okay, so so what's going to happen tomorrow? Do you have any idea?
And then we're gonna wake up very early and we're gonna get on a bus and go to a launch site that's about 5.5 miles away from the rocket. And then we're gonna get to watch it sometime, hopefully launching between 5:35 and 6:20 something.
Yes.
Tomorrow.
Okay, so that's the window basically of launch. And they mentioned to me in the bus that if we miss this window, there is another one the day after at more or less the same time. We'll be still in Florida, so we try. Will you be still in Florida?
Yes.
I will be, yes.
Okay,
We'll try again.
so we will try again. But the weather is, as you can see, amazing right now. We are basically almost melted outside for the first part of this SETI Live because it's very warm. There is almost no clouds. They said that there is no strong wind as well. So everything is optimal. That's the term they use to watch the magnificent launch of the Lucy mission tomorrow. And someone asked one more question: if we could detect other objects with Lucy, like Oumuamua. I can answer to this because Lucy is not a mission to map the sky. It's a mission to study objects which already have been detected and we know they exist. Something I mentioned that they also told us in the bus is that the mission is supposed to last for 12 years. So if everything goes right, we are going to have pictures of all those Trojan asteroids, but there is a possibility to extend the mission later on.
Yeah.
And probably what they will do like we did for New Horizons. They will wait to find some very interesting target to launch the spacecraft to explore those. So if an object like Oumuamua is passing, Oumuamua is an asteroid which was coming from another solar system, another planetary system. So if a target like Oumuamua is passing by and can be visited by the Lucy mission, I can guarantee that we will launch it toward this location to explore it. That's definitely something that we'll be able to do.
And it's going to continue in orbit for another 2 million years.
Yes, so we
they
have
said?
plenty
Yeah.
of time. So in 2 million years,
Little 6-year
Yeah.
6-year orbits out to the Jupiter.
yeah, then it will become probably slowly unstable and start coming back to us or crash into our sun. But it's gonna be in 2 million years,
Yeah,
so
that's a
it's not
while.
our problem. Maybe it's Arin problem because he's the youngest. But
Yeah, we'll see. We'll see.
Yeah. Okay. Anything else you want to add? You good?
Very
Oh, yeah?
excited to be here.
Yeah.
Me too. Very excited to see you in person. I mean, it's kind of nice to see you in 3D, all of you. I mean, it's and it's as usual when you see someone on Zoom only, and when you see them in person, I'm always surprised by the height. I don't know, Kevin. I thought you were way shorter than that.
I always thought you guys were only this big.
Yeah. Okay. And flat. And only your head. No.
I would just say this: if there are any other citizen astronomers out there, join the Slack and get involved. It's amazing when you get to do something like this, but it's even just rewarding to know that your little bit of contribution, your little bit of data is helping somebody somewhere with their research. And we don't know where that research is going to lead or the value of that research, but that's the way science has always been.
Yeah.
Lots of, we only learn about the big aha moments or uh-oh moments. But science is mostly done incrementally in tiny little fractions, and to be part of one of those little tiny fractions of knowledge is exciting for me.
And I will say that sometimes discovery that we make, we think they're tiny, but at the end becomes a big deal. Like the finding of Oumuamua is one of the big deal of the past 10 years. The discovery of rings around centaurs is a big deal because that's not something we expected. So each of us can contribute to science and can participate to this great conversation called the scientific research. And I will mention that there is a new occultation involving Eurybates, and it's gonna pass above northern part of San Francisco, Las Vegas, all the way to New Mexico. So look on unistellar.com and click on Science Asteroid, and you will see the path of this occultation. And this is once again one of the targets of the Lucy mission. And is one of them that is one that we did not yet observe with the Unistellar network. So I hope the weather will be nice in the northern part of California. So we have multiple citizen astronomers to observe it like you did. And of course, if you want to come to San Francisco, you're welcome to come on October 20th. It's next week. You're invited to observe the occultation by Eurybates. Okay. Well, thank you very much, everybody. Thank you, Esteban, for your very nice comments. I did not read them yet, but I know that they're very nice. You just told me that. Thank you. And thank you everybody at SETI Institute. Sorry, it was a bit complicated today, but I think at the end we managed to do it as usual. Next week, we have an interesting SETI talk. We are going to talk about black holes. So that's something completely different, but that's great to watch them and to learn about black holes and why they are so important to understand the structure of the universe. And join us at SETI.com, SETI.org, to learn more about our outreach and communication activity. This SETI Live is a product of the SETI Institute, and we are streaming as well at the moment on Unistellar YouTube page. So because this is a project, a partnership between SETI Institute and Unistellar. So if you want to help us, you can help the SETI Institute, the nonprofit organization, by making a simple donation. Go to seti.org/donate. You can also simply join the conversation, join our social media, register to receive our newsletter. They're very cool. There is always some cool stuff happening in space. And we are trying to make sure that we write about them and make sure that they are clear for everybody. So you learn about the excitement of in the field of astrobiology. Very useful to talk about it at dinner party, for instance. Okay, well, thanks a lot, Kevin, Brad, Rachel, Arin. I hope to see you soon in Florida. But tonight, don't forget to wake up. 2:30.